Okay, let's go. Man, it's today, Wednesday. Wednesday. I hope you're doing okay. I hope your days are going all right. So I thought I'd throw a picture of me in here. This was my yearbook picture from 2017, 2018. I shouldn't have wore a black shirt because you can't see uh, my sideburns. I look like Wolverine, except not. Okay, for today, let me hit the focus here so we can get focused. We're going to review again, sixth review, and it's going to be covering fractions again. This time, how do I multiply and divide fractiones easily? Um, People's least favorite pizza topping, fractiones. Okay. You're right. I agree. I agree. I should just start and not, I should dispense with the humor. All right, let's go. There's two parts of this there is the multiplying, then there's the dividing. So, multiplying, we'll do that first. Very simple. Simple algorithm. And what that means is that's just process for multiplying fractions. And this is where, like in my head, usually what I think to myself is don't worry about the numbers. Like my numbers, let me move this. This is no, I'm not going to move it. I'm leave it here until it's gone. We'll let it fade away. When I do this, my number sense kind of goes out the window. My number sense, literally. So as I'm multiplying these things, they're they're values, but they're values that are really hard to conceive of in our minds. So when we do this, we're just going to multiply numerator, and I'm going to use the big X here, times numerator, and then denominator times denominator. And that's it. And then we might have to simplify over here, but we don't know yet. Let's try one. So for multiplication, let's just do 2/3 times 4/5. So I'm going to do numerator to numerator. 2 times 4 is 8. Denominator to denominator, 15. So I got 8/15. That was it. Let's do another one. I got 7/6 times 11/3. I mean, I could put a middle step in here and write, 7 times 11 and 6 times 3, but I don't know what we're wasting the ink or pencil lead for that. 7 times 7 is 77. 6 times 3 is 18. I could check to see if these have a common factor, but if I go back and look at these numbers, 7 and 11 are prime, so they have no factors besides themselves. And 6 and 3 don't go into 7 or 11, so this should be done. Boop, boop, boop. Let's try one. Try one on your own here. 1/5 times 5/4. And let me wait like 10 seconds. Wait like 10 seconds. So I'll watch my clock here. All right, that's enough. I get 5/8. 1 times 5 is 5. 2 times 4 is 8. Boop, boop, boop. Done. Now, in my head, I'm like 8/15. Like, I kind of know that's about a half. 77/18, like four holes and something else. 5/8. you know, whatever, like 60%, something like that, 50%, a little more than 50%. But it's not necessarily important for me to know exactly what these values are, just to know that they are correct because my multiplication is correct. All right, let's try division then. Division or divide. This also is a simple algorithm. So instead, though, with this one, we want to multiply, and there's a way to do this. I could kind of show this to you. I can show this to you over here on the side. So here's my proof of reciprocal. My proof of reciprocal. If I do 2/3 divided by 4/5, I can write that as a fraction, 2/3 over 4/5. And then I want my denominator to be 1 because I don't want a fraction in my denominator, so I'm going to multiply that by 5/4. Well, if I multiply the denominator by 1, I can multiply the numerator by 5/4. And you can see how we get 4 times 5 is 20, 5 times 4 is 20. That in essence makes our fraction over 1, which leaves us just this problem to do, right? And all we did was, instead of divide by the second fraction, we just multiplied by its reciprocal. That's the proof of it. So for this, what we're going to do is we are going to, instead of divide, and there's a way to actually divide too, but it's with common denominators. We will multiply the first term by the reciprocal of the second term. Nothing earth-shattering here, and something you've already learned. So let's do one here. 2/3 divided by 4/7. So first thing I'm going to do, I don't want to remember this stuff. Like, I don't want to make my brain have to remember everything that I'm doing. So I'm just going to write 2/3 times 7/4. I'm using my parentheses now because I want even less to think about in terms of symbols here. So 2 times 7 is 14. 3 times 4 is 12. We have a common factor of 2. Like, you could go back and check the other side of your multiplication chart. We have 2 even numbers, so we can divide both those by 2 and get 7/6. Totally fine. Let's do another example. I got 17/6 divided by 3/5. Now, just to reiterate, my number sense is going to be entirely built here on the fact that I'm doing the math correctly. And I trust the algorithm. So I don't necessarily know what 17/6 is. It's almost 3. 3/5 is about 60%, or it is 60%. But in my mind, the answer that I'm going to get, it's 3/5 of almost 3. So let's see what happens here. Rewrite it. This one stays the same. This one gets the reciprocal. And we switch to multiply. 5/3. I put the dot in this time just to show something different. 6 times 3 is 18. 17 times 5. Let me do 17 times 5 over here. 35, carry the 3. 8, 85. 85/18. Do I know what that is exactly? No. Do I need to? No. I trust my math, so I know this is my answer. I can leave this as an improper. Improper is fine because it's simplified. Simplified. Oh boy. Don't write that one. Let me quick check here. I'm looking at 17. Oh, there's my face again. Watch out. Check my 2. Are they both even? No. Check my 3. 1 plus 3, 1 plus 8 is 9, which is divisible by 3. So 18 is divisible by 3. We should have known that because that 3 there. 8 plus 5 is 13. 13 is not divisible by 3. So these are not both sharing a common factor of 3. And they both don't end in a 5. So I think we're okay there. Let's flip it over. We'll do one more little practice one here for division. How about 1/6 divided by 8/11? Let me give you 20 seconds to give that a try. I don't want to sing anything because if this goes on YouTube and then YouTube's like, you can't use that, and then I've got to do all this over again. That's a pain in the booty. All right, let's rewrite it. 1/6 times 11 over 8. Totally fine with that. 1 times 11 is 11. 6 times 8 is 48, and we're done. Does this number mean something to me? Yeah, it's about a fourth. Does that mean that I understand what this is? Kind of. I mean, what you're doing is you're taking 1/6 of something. Let's see if I can draw this. This is really a bad idea. So I need 5 lines. 1, 2, 3, 4. 1, 2, 3, 4, 5. Oh boy, this is really bad. 6. There's 6. So, and then what we're doing is we're taking 1/6, that's right here, and then dividing that into 11ths. So I need 10 lines here. So like 1, 2, 3, 4, 5, 6, 7. This is a terrible. I'm in trouble here. 8, 9, 10. Like that's really horrible. So full apologies for that. So what we're taking is that 1/6 and then dividing it into 8/11. So we need 8 of these. So that'd be like 1, 2, 3, 4, 5, 6, 7, 8. So it's that much of this shape if I'd drawn it more to scale, which is 11/48. That's what I'm telling you. Like, don't necessarily worry about what exactly these things are, except be confident that you're doing the math correctly, because the math is proven out. Okay, so if you have questions, you can ask me, you can ask Mrs. Leck, you can ask any of your previous math teachers, you can ask current math teachers that are on the staff at this grade level that you do not have. Now would be a great time for you and your teacher to do some practice or get started on the homework. Good luck.